Let me do a problem to find the half-range sine Fourier series. When you look back to the previous lectures, we have already discussed that half-range sine series are series when we have a function in odd form. This problem is going to be exactly the same problem as we have done for the odd function previously. But it's okay. Let me do one more problem here. Find the half-range sine series of 2 plus 6x in interval from 0 to pi. Here I'm going to find the half-range sine series where f of x equals to 2 plus 6x. Solution. The formula for the half-range sine series is here f of x equals to summation of b sub n times sine nx. If the function is odd function, we had half-range sine series. In half-range sine series I have only b sub n. A sub naught, a sub n are 0. So therefore my formula for the half-range sine series is summation of b sub n times sine nx. Now I'm going to check whether the function f of x, which is 2 plus 6x, is odd function or not. That is the first thing to do. Very simple, just multiply the variable x by minus, which equals to 2 minus 6x. So this function is not my f of x because my f of x is 2 plus 6x. Therefore 2 plus 6x is odd function. Now it is confirmed that the function is odd function, which means that we are on the right track to find the half-range sine series. Find b sub n, where the value of b sub n equals to 1 over pi into 2 times integral of 2 plus 6x times sine nx dx. This is the basic formula for b sub n. So here I have the product of two functions. One is algebraic function, which is 2 plus 6x, and the other is trigonometric function, which is sine nx. So you already know that if we have the product of two functions, we normally use integration by parts process here. So the common formula that we use for integration by parts process is here. But since I have one pure algebraic term which is 2 plus 6x, therefore I'm going to apply the other method. Put differentiation at one side and integration on another side. Take the algebraic term under differentiation and trigonometric function under integration. Derivative of 2 plus 6x is 6. Integration of sine nx is minus cos nx over n. Derivative of 6 is 0. Integration of minus cos nx over n equals to minus sine nx over n square. I'm going to stop the process here because I got 0 at the left side for differentiation panel. Put minus plus minus. Take cross product here. The product between these two terms is minus 2 plus 6x times cos nx over n. And the product of these two terms is plus 6 times sine nx over n square. This is going to be my final value. Just put it here. Now expand the limit 0 pi, where all the sine functions are 0. Cos n 0 equals to 1. But it's still 0 because it is the product of 0. So I only left with minus 2 plus 6 pi times cos n pi over n, which equals to minus 4 plus 12 pi over n pi times cos n pi, which equals to minus 4 plus 12 pi over n pi times cos n pi, where cos n pi equals to minus 1 to the n. It depends on the value of n. So this is my final value for b sub n. Just put it here. Let me substitute some values for n. If I put the value of n equals to 1, this term will be 4 plus 12 pi over pi sine nx. When I put n equals to 2, this term will be minus 12 pi over 2 pi sine 2x. When I put n equals to 3, this term will be 4 plus 12 pi over 3 pi sine 3x. And finally, when I put n equals to 4, this term will be minus 4 plus 12 pi over 4 pi sine 4x. This is my final half-range sine Fourier series. If I have the function 2 plus 6x, which is defined in the limits from 0 to pi.